Hello and welcome back everyone. Into this video, we're going to talk about more into actuators and more into our other topics that are going to be important. Slowly, you might have seen that we are moving from actuators to sensors to controllers. And this module, specifically module 2, is all about that. So in this module, we have chapters which are designed and aligned in such a way which is going to give you a very good understanding of use cases and equipments which are used, and also how do you align them and how do you plan them, so that they can help you in the best possible way to improve your robotic skills, of course. And this chapter is one of those. I'm not sure how much have you understood on those topics where we are using blocks. Okay, so this chapter is going to give you a very good understanding of how block based concepts help you build a better understanding of robotics, and how each and every step or each and every block builds upon the robotic structure and gives you a very good conclusive robotics solution. Okay, so without any further ado, let's actually jump into the chapter and understand what I'm going to talk about. Okay, so we are back. We're on chapter 5, module 2, and let's start. And this chapter is on the second blocks, or the second block which is we are using, which are sensors. Okay, so essentially speaking, as I mentioned before, this chapter is going to give you one of the blocks which is very important, which is sensors. And as we have seen in the previous videos as well, when we talk about our little robot that I have on my table, this one. So even when we talk about this little device, sensors are one of those things which help you understand the physics which is happening around. Okay, the physics which is happening on the environment, the physics which is happening on the robot, and how do you deal with it. And that's something which is going to help you build the understanding of this. Okay, so sensors are components used to detect and measure physical quantities such as light, temperature, and pressure. That's an important thing. Then sensors are essentially essential components of robotic system, as they allow the robot to perceive its environment and make decision based on its perception. Now we're talking about perception. Perception means that a robot is going to have its own vision and understanding of the things which are around them. Now, this not only allows and open doors for a robot to explore, but it also opens door for robots to understand the physical entities which are around it. Okay. Now, when I say this, it means that, we are essentially speaking that, if something is happening around the robot, how are we dealing with it? How are we concluding that there is something which is happening around it? And if something is happening around it, what do you want the robot to do next? Okay. All of the decisions are only possible when we say that, there are sensors which are equipped to detect it, of course. So, if the robot is not having a camera, then it cannot detect that there's a human being in the front. Okay. There needs to be some sort of vision system which is going to detect that there's a human, and the robot can say that, okay, there's a human being in the front. And all of these decisions make upon the fact that, this robot is going to work on this space, or this robot is not going to work on the space. Okay. And these decisions also helps you to understand that, the robot is actually capable of doing this or not capable of doing this. Perfect. We got that thing sorted. Now let's move ahead. And there are several types of sensors used in robots, including optical sensor. The first thing that I talked about is an optical sensor. Now, let's take the example of a phone. Okay, in a cell phone, in a smartphone actually these days. In a smartphone, you have cameras which are on the back, and optical sensors are nothing but cameras. Okay, optics basically means lights. Okay, so optical sensor detect lights and can be used to measure distance, color, and position. Okay, if a sensor is present at an orientation, or if a sensor is capable of doing certain tasks, okay, how is it helpful? Okay, and how is it going to, help you boost the overall productivity, or how is it adding any benefit to the system? That's why is very important. Okay, if you have like a dual camera system like these days on an iPhone, okay, and some iPhones actually have 3 cameras like this one. So depending on which iPhone you buy, all of these iPhones actually give you the possibility of having more and more features every other camera you add. Okay, with 2 cameras you can do like depth analysis. With 3 cameras you can also do I don't know what is it called, like 3x zoom or something, or some digital zoom, something like that, because they keep on changing the software. And I think this is a little old one. This is a 11 Pro, so I think they have, for this one they actually didn't really have depth video, but with the 13 mini they actually had like depth video. So quite a lot of features they keep on adding all the time. So, but the main idea remains the same, that, with more and more optics, coming into play, you can do a lot more in as compared to, what was even possible before. Now, example of optical sensor used in robotics include cameras, laser rangefinders. Laser rangefinders or LiDARs, okay, laser rangefinders are used for estimating distances from the robot, and quite a popular, equipment which is used to determine, where the robot is present in the room, and, what it has to do next, okay? If it has to go from room A to room B, It's going to figure out how much wall distance does it have, and based on that, you can conclude, okay, there is a lot of space on the right, so move right. There's a lot of space on the left, so move left, and things like those. When you talk about all of these things, it certainly brings onto the topic that, a robot is capable of doing things depending on the sensor that it has. Okay. So this gives us a very good understanding that, if you have a lot of sensors which are powerful enough, you can do a lot more as compared to, not having any sensors at all. So keeping this in mind, okay, and keeping this perspective in mind helps you understand that, okay, what, maybe a robot is doing just exactly what you want to do, but the sensors are not capable of, telling if that thing exists or not. Let's say you want a robot to go from your bedroom to to your kitchen. In that case, if a robot is not able to navigate from your bedroom to the kitchen, probably it's not the fault of the algorithm. It might be the fault of the cameras. Okay, maybe the cameras are not too strong, or maybe they're not able to give the information that the robot needs. So there can be a very big bottleneck when you're selecting a sensor. So sensor selection is another aspect of it, which plays a very important role. Okay. Then you have tactile sensor. We have talked about this before. Okay. Tactile sensor detect pressure and can be used to measure contact forces and surface textures. Okay. Let's say you want to make a robot which is going to interact with the humans, and let's say the robot looks like this. Okay. This is a real cute robot. And I want, whenever I tap on the head, okay, it starts dancing or start doing something. How do I detect those taps? Okay, those taps can be detected with the help of a tactile sensor. A tactile sensor is nothing but a pressure sensor which helps you understand and convert these touch, okay, into something which is going to add more value to the robot information. Okay, it can be motion, it can be, taking a pause, it can be making a dance move, it can be anything. Okay, the main idea over here is that the robot is able to understand what you are trying to say, and is able to do actions depending on what you are trying to what you want to, obviously put in the program. So all of these things are only possible only if you have a tactile sensor. Okay? If you don't have a tactile sensor, then it's impossible. So tactile sensors are commonly used in applications such as robotic grippers, prosthetic hands. Okay, inertial sensors. Okay, then we have inertial sensors. Now, inertial sensors measure the motion, orientation, and can be used to provide information about the robot's acceleration, velocity, and position. Let's look at this in this way. Okay, when you talk about inertia, okay, it means that, a robot is moving, and when a robot is moving, you want to understand so many things. Let's say you want to understand if the robot is going fast or if it's going slow, or if you want to use a GPS to measure the location. Usually when you talk about any industrial GPS, an industrial GPS doesn't rely only on the GPS signals. It relies a lot on the inertial sensors as well. Okay, because what happens is, let us suppose you're going inside a tunnel. In that case, your GPS signal will go away. But the inertial signals, of course, from the IMU or the inertial measurement unit will still be there. In those cases, since we have those data, we can predict, how fast or how far the robot could have been, and we can estimate in a range of possible values where the robot location is possibly present. And this data helps a lot, when we have, where we have a car accident and when the robot is, upside down or something. So it's pretty easy for us to, figure out, okay, if there is a problem, and how we can solve that off. Examples of inertial sensors includes accelerometer or gyroscope. Accelerometer is nothing but like a small sensor which measures acceleration, and gyroscope is for orientation. If the robot is up moving straight, or if it has tilted or something, you can figure that out very clearly with a gyroscope. Then you have force sensors. Okay, force sensor measures the force applied on an object and can be used to measure contact forces and gripping force. Okay, let's take a hypothetical example of a robotic gripper which is trying to grip something. Okay, let me pick up something which is very cool. Again, close. Let's take this glass bottle. Okay, this is my cologne. Okay, and this bottle, if I am gripping like this, okay, probably since this is made out of glass, I would require much less force as compared to if I have to hold something which is much more stronger. Let's say I have to pick up my phone. Okay, or from the sides. Okay, in that case, probably I would apply much more higher force as compared to a glass bottle. Okay, now a force sensor does exactly the same thing. Okay, when you are pressing it from the side, you want the robot to grip, or you want the robot to handle this situation in a much more planned way. Okay, you don't want the robot to grip it very hard so that the glass breaks and things like that happens. So those kind of things keep the robot in mind. The robot keeps in mind and makes decisions sensibly. Force sensors are commonly used in applications such as robotic grippers and exoskeletons. Exoskeletons are basically human support skeletons which help you to walk faster, walk much more efficiently, and do things which humans cannot do normally. Importance of sensors. Sensors are important in robotics because they allow robots to perceive its environment and make decisions based on the perception. When we're talking about perception, okay, it's very important for you to understand that perception doesn't only happen through, just basic things which are around the environment. It also happens majorly with the help of, the sensors that are there. If you have a lot of sensors, then you can perceive the environment in a much more efficient way. Sensors provide the robot with information about its surroundings, enabling it to perform tasks such as recognition, navigation, manipulation. We already talked about this. Now, some examples of other robotic sensors which are there. Okay, cameras for detecting or recognizing objects in the environment. Let's say you have a robot with a camera. You can recognize, where's a TV, where's a bed, and things like that. Then you have LiDAR, as I talked about before, laser range finding, okay, which are used for measuring the distances of objects and then create a 3D map of the room. Okay, you can create a 3D map of the entire room and see where things are, and it's quite practically helpful. Force sensors for measuring the force applied onto a robot, allowing the robot to grip, manipulate, and with precision. So if you want to precisely grip something, you can use these force sensors. Then you have the IMU, which is initial measurement unit, which is used for navigating and avoiding obstacles, of course. In conclusion, sensors are essential component for robotic system, allowing the robot to perceive the environment and make decisions based on perception. When you're perceiving the environment or when you're perceiving the system which is around you, you're essentially allowing a robot to understand and figure out a lot of things which humans cannot do normally. Okay, and that's the main point. There are several types of sensors used in robots. Okay, including optical sensor, tactile sensor, inertial sensor, and force sensor. Okay, you have a lot of sensors depending on which use case you want to fall into. You can obviously select those. Understand the different types of sensors and their application is essential for designing and building an effective system. When you want to optimize or when you want to make sure that you get the best system out of the current situation, you would try to maximize the amount of sensors, but also try to understand that you might be better off buying a much more efficient sensor as compared to a sensor which is much more cheaper. So those things or those decisions are quite important. And that's it. Okay, we do a very exciting chapter actually. Yeah. So, very exciting chapter actually. You can find a lot of sensors that are used in robots. Typically in your smartphone, in your iPhone or in your Android phone, you can find a lot of sensors which are almost the same as there in robots. Okay. And even these days on iPhones, you have a LiDAR. Okay, which helps you to map your room and everything as well. Very cool. And yeah, I would say if you are still new into sensors, maybe you can go through the video once more. And hope you had enjoyed this video. I'll see you all in the next one. Till then, happy learning and peace.